Welcome to the video on derivatives of trigonometric functions, part 1. In this first part, we're going to introduce the derivatives of trigonometric functions, and specifically we're going to find the derivative of the function sine of x. So the derivative of any trigonometric function can be found once we know the derivative of the two basic functions. The two basic functions are the functions f of x equals sine of x and g of x equals cosine of x. Once we know the derivative of these two functions, we'll be able to find the derivative of any other trigonometric function. So in this video we're going to begin by finding the derivative of sine of x. We need to remember the trig identity, the identity that tells us what is the sine of the sum of two angles. This is identity. Now let's consider the function f of x equals sine of x, and let's try to find its derivative. By definition, the derivative of a function at the point x, it is the limit of delta x up to 0 of this quotient here. And to find the derivative of a function, in this case sine of x, we need to replace here f by our function that is sine. So here replacing, we get the limit as delta x approaches 0 of sine of x plus delta x minus sine of x over delta x. And now here we apply this identity for this term here. Here we have the sine of a sum of two angles, and using the identity we can replace this by this expression. This is the sine of the first angle times the cosine of the second angle plus the sine of the second angle times the cosine of the first angle. So we have this limit here. We need to solve this limit, and what we can do here, we can, between these two terms here, we have a common factor that is sine of x. So here we factor sine of x, we get sine of x times cosine of delta x minus 1 plus the other term. Now we can separate this limit into two limits, the limit of this first term plus the limit of the second term. And here we can take sine of x out of the limit sign, because here we're taking the limit as delta x up to 0. So delta x is the variable, and we can take x as a constant. So sine of x is a constant, and we take it out of the limit sign. Now we do the same with cosine of x. We take it out of the limit sign. And here we have something interesting. We have the limit as delta x up to 0 of sine of delta x over delta x. And we know that this limit equals 1. We prove this using the squeeze theorem. This is the fundamental trig limit. So what we're going to do now is to show that this limit equals 0. Once we prove that this limit equals 0, we'll have that this term will be 0, because it's sine of x times 0, that's 0, plus cosine of x times 1. So the derivative will be simply cosine of x. So what we need to do now is to prove that this limit equals 0. We're going to solve this limit separately, like this. We can multiply the numerator by minus 1 and divide by minus 1, so we can take the minus 1 out of the limit sign. So here the signs are reversed like this. Instead of cosine of delta x minus 1, we get 1 minus cosine of delta x. And now we're going to multiply and divide by the conjugate of this expression. That in this case is 1 plus cosine of delta x. We do this because if we multiply these two factors in the numerator, we get the difference of squares like this. Here we just multiply these two factors. We get this difference of squares, but using a true identity, this becomes sine square of delta x. So we replace that, and we can separate this limit into two limits. Because here we have sine square of delta x, we can put one of the sine of delta x here and one of the sine of delta x over here. Here again we get the fundamental trig limit that equals 1, and on this limit we have sine of delta x on the numerator, but delta x approaches 0, so sine of delta x also approaches 0. So, and cosine of delta x approaches 1, so this limit equals 0. So all of this equals 0. So we've shown that this limit equals 0. So we have that f prime of x equals sine of x times 0 plus cosine of x. That equals cosine of x. And that's our conclusion. And another way to put this is using this notation, using a Linus notation. We say that the derivative of sine of x with respect to x is cosine of x. So that's all for now. Thank you for watching, and see you next time.